Okay, so for number 11, everything looks like it's set up great, and then for the equations part, that one looks great. For this one, we're having the price of each ingredient multiplied by the pounds of that ingredient. And what that's going to equal to is the total pounds of the entire mixture and multiplied by the price of the entire mixture. So 6 times 140, I think that will come out to 840. So you can just write 840 there. But just like on this side, it's the pounds of each ingredient times by the price. Over here, it's the total pounds times by the price. And down for this one, there are twice as many pretzels as dried fruit. So to get this set up, the pretzels and dried fruit is what we're going to have in the equation, just the x and the y. But the number of pretzels, the x, should be 2 times as big as excuse me, as the dried fruit, the y. So you're actually going to have x equals 2y. So there are actually a couple of ways you could finish up. If you want to use the traditional method we've been using to solve the 3 equations, you'd want to subtract the 2y here from both sides. So you get x minus 2y, and then there are no z's. It's helpful to put a 0z in there as a placeholder. And everything is subtracted from the right side, so it'll be 0. So redo that equation by subtracting the 2y's to get this, and now you have your 3 equations, and the x's are all lined up, the y's are lined up, and the z's are lined up. And you can do it like we've been doing in class, where you eliminate the x from that equation and then the x from there, and then you eliminate that y and get the stair-stepped look. Another option that you may want to do, it's a little quicker, but it is different. So if you don't like it, stick to what we've been doing. But since x equals 2y, you can go ahead and make a substitution in each of these 2 equations. So x is 2y, you could write 2y there, and instead of x, here you'd write 2y. So now for you're just going to have 2 equations. It'll be 3y plus z equals 140. Here would be 6y plus 4y, so 10y plus 8z equals, and then 6 times 140 is 840. So now you just have 2 equations because you've substituted in place of x, you wrote 2y. And then use either addition or substitution like we did back in 6.1 to solve these 2 equations, since there's just 2 of them. And after you solve for x, or for what y and z are, you can use this fact that x is 2y to get what x is. Okay, and now for your next question was about number 51 on page 363. So for part C, they add a 0 here just to make all the decimals have 6 spots in them. You can add a 0 on after a decimal point. You can add as many zeros as you want, and it doesn't change the value. For example, 4 is the same as 4.0000. You can add as many as you wanted. So the only reason they added a decimal point was so that all of the numbers would have 6 decimal points. It's a similar concept to if you have a number, you can always add zeros in front of it, and that's still the number 1. It just has a 0 in front of it, and people sometimes like to write it that way just because they think it looks nicer for whatever reason. But yeah, so for C, the 0 is just added there to make every number have 6 decimals. For D, let me check in the book what it says. Explain what A times B represents. So when you're multiplying this matrix, you're taking the population from all 4 of these countries in 2001, and you multiply it. The first thing you multiply it by is the birth rate in all 4 of these countries in 2001. And let me expand my window a little bit here. So when you do this, you're doing the US population times the US birth rate, the Canadian population times the Canadian birth rate, Argentinian population, Argentinian birth rate, and then Japanese population by Japanese birth rate. And you add all those numbers up, those 4 multiplications, you add them together to get this number. So what that is the number of people born in combined in all 4 of those countries in 2001. And then again, if you take the population of the US and multiply it by the death rate, just that gives you the number of people who died in the US in 2001. But then you're going to add it to the population of Canada, gets multiplied by Canadians' death rate, which is the number of people who died in Canada, and so on. So what you get is the number of people who died altogether in those 4 countries. And the next row is very similar. It's just the stats for 2010. So when you do this row times the first column, the first thing you do is the number of people in the US times the birth rate, and that's the number of people born in the US. And then as you continue doing the multiplication, you're adding the number of people born in Canada, and then the number of people born in Argentina, and the number of people born in Japan when you do that final multiplication. When you add them all together, you get the number born in all 4 countries combined in 2010. And then similarly, this is the number who died in all 4 countries combined in 2010. So that's D. And E says, according to the matrix A times B, what's the total number of people born in the 4 countries in 2001? So in 2001, the number born is 6.177505 million. Remember, our populations were in millions. So that's where they're getting the answer in the back of the book. It's just this number written as a million. So 6 million and then 177,505.